everybody. Today we are going to be talking about inverse, direct, and joint variation. And today's lesson is going to be very short, so you should be very appreciative of that. All right, so three equations up here. We have direct variation, kx, inverse variation is y equals k over x, and joint variation is basically the same as direct variation. You just have more than one variable going on. K is a constant. It is not a variable. It's called the proportionality constant. Okay, and so whenever you hear something is directly or inversely related, or you're talking about they're proportionally related, this is referring to some sort of direct, inverse, or joint variation. Okay, so let's take a look at some examples. The time t that it takes to get to school varies inversely with your average speed s. All right, now what this is telling you is that they tell you time t varies inversely with speed s. So you're going to start with a t, time equals, inversely means your k is going on top, your speed is going on the bottom. Now, letter A says it takes you 40 minutes to get to school when your average speed is 30 miles per hour. Express the driving time to school as a function of average speed. Essentially what they're asking you to do here is to solve for k and then rewrite your equation. So 40 minutes is your time, k is what we're trying to find, and your speed is 30. Okay, and then we'll just either cross multiply or multiply both sides by 30, and we're going to get k is 1200. So this is a constant now. Every single situation like this will have a constant, and we'll go ahead and we'll plug that back in. And so your equation is t equals 1200 over s. Okay, so kind of like when you were finding a for your parabolas. All right, determine how long it will take you to get to school if your average speed is 40 miles per hour. So now they would like you to use the equation you just wrote. They've given you speed, and we are just going to plug in 40 and evaluate, and you should get 30 minutes. And that's it. All right, let's try another one. At the corner Shell station, the revenue R varies directly with the number of gallons of gasoline sold. So revenue varies directly with number of gallons of gasoline sold. That tells us that revenue equals K times, because it's directly, and I'm going to say G for gasoline. If the revenue is $23.40, when the number of gallons sold is 12, find a linear function that relates revenue R to number G of gallons of gasoline. Okay, so again, they're asking us to find K. Plug in what you have. Revenue is $23.40. K we are looking for. Gallons was 12. And then we'll just go ahead and divide. And I got $1.95 is K. All right, and then we need to plug that back in. So okay, and now find the revenue R when the number of gallons of gasoline sold is 10.5. Okay, so now our 1.95, that's our constant. Our gasoline sold is 10.5. And I'm going to take my 1.95. Oh, I typed it in wrong. Times 10.5. And I'm getting, I don't know how to do this. 20.475. But this is money, so we want to round to the nearest hundredth. 20.48. And then make sure you have a dollar sign. All right. Finally, the maximum safe load for a horizontal beam varies jointly with the width of the beam and the square of the thickness of the beam and inversely with its length. Whoa, there is a lot going on here. All right, let's see if we can write this. So Maximum safe load, I'm going to say that's S. Varies jointly. Okay, we have a K with the width of the beam, W, and the square of the thickness. Okay, square of the thickness meaning T squared. And then inversely with its length, that means we're dividing by L. All right, so then we have if an 8-foot beam will support up to 750 pounds when the beam is 4 inches wide and 2 inches thick, what is the maximum safe load in a similar beam 10 feet long, 6 inches wide, and 2 inches thick? Again, we're going to need to find K first. Okay, so let's see here. We have length was L, width was W, thickness was T, and let's just start plugging stuff in. 8-foot beam. So an 8-foot beam, that would be the length. Will support up to 750 pounds. That's your safe load. There's a K up here. When the beam is 4 inches wide, that's W, 2 inches thick. So it's not just 2, but it's 2 square. All right, so let's go ahead and solve that. 750 equals, that's 4 times 4 is 16. 16 divided by 8 is 2K. And then if you go ahead and divide, we should get K is 370. That's going up there. Okay, so now here's the equation that we're working with, and then we can plug in these new values. So what is the maximum safe load in a similar beam 10 feet long? Whoops, changing my constant. 6 inches wide, 375 times 6 times 2 squared is 4, divided by 10, and I'm getting a 900. So your safe load is 900 pounds. And look at that, after all those super long videos, we have one under 10 minutes long. Okay, congratulations. This is the last topic on your quiz. Please let me know if you have any questions. Bye.